Hello, Rulan, how are you?
I'm
Hello.
good, ma'am. Hello.
Yes, I can hear you. It's fine. Is the screen sharing now?
Yes.
Okay. So that question which we are referring to, the one which we were saying you don't understand the working. Remember?
Yes.
Right. So which part is it that you didn't understand so that we can clarify it? That we can clarify.
The signs, like, let's say I'm taking upwards as positive, right?
Yes, from the calculations here, they are saying let's start with upwards as positive. So we are saying if we start as upwards as positive, and remember, how are these balls? These balls, we are having ball A and ball B. So 1 second late or 1 second after, a ball A is projected upwards. A second ball B is thrown vertically downwards. So we are saying from the first option on the marking guide is taking upwards as what? As positive, isn't it?
Yes.
So it's upwards as positive. So if up is positive, I want to calculate the change in Y of ball A. I want to calculate the change in Y of ball number A. So which means this is the formula for change in Y. VI, change in Y of ball A is VI delta T plus half A delta T squared. Are you fine with that one? The formula first.
Yes.
The formula,
Yes.
yes. Then now we are going to the substitution of that formula while we are interpreting what is happening there. Upwards is positive. So your change in Y, if up is positive, and you are talking of ball A, how was ball A projected? Ball A is projected from the ground, going upwards. So my reference point is the 0. So which means if I want change in Y, how do you write change in Y? If you want change in Y. So we know that change in Y is equals to the YF, Y final, minus Y what? Initial. Is that correct?
Yes.
So Y final, it will be as the ball is being projected upward, any height which the ball will reach as it is going upwards, we call that value Y final is just YA. Then the Y initial is where this ball is starting from. The ball is starting from 0. Is it clear? So which means
Yes.
after any given point time, the position of the ball, we call it YA. YA at any given point in time, it's at YA. Why are we saying YA? It's because the ball has been projected upwards. So we are taking Y as positive. So YA is our final. And then Y initial, it will be 0. So that's why here it's YA minus Y0. That is the change in Y. Then now we go to the issue of the VI. Since the direction of the velocity is upwards, we are taking upwards as positive, and the ball A is being projected upwards. So which means up is positive, which means it's a positive 16. So this VI is a positive what? 16. Why is it a positive 16? Because it's going upwards. And we know if your ball is going upwards, the acceleration, it's always negative 9,8. Do you agree there?
Yes.
Yes, that's why that equation has been set up like that for the first part. So solving for YA, which means the negative, it will give you a negative half times the negative. Yeah. Half times the negative, it will give you a negative 4,9 delta t squared. Negative 4,9 delta t squared. So which means your final equation for YA, is that one. YA is equals to, then it will be 16 t squared minus 4,9 minus 4,9 t squared. That's where we arrived at that point as our equation 1. Any point, any question?
No.
It's for this part first, for the YA. Before we go to the one for the ball B, for YA, do you have any question for YA?
No, I don't have any question.
Right, let's go to YB. We are still taking upward as what? As positive. So if you go to YB, which means the direction of B, the ball is here. And if the ball is there, which means it's projected downwards with a velocity, and this ball here, it's 9 meters per second. And we know from where it's projected to the final point, it's 30 meters. It is below. So which means that height is 30 meters. So from that point,
Sir,
yes, ask. The height of this building is 30 meters. So from where it has been projected, this ball going downwards, the initial velocity was 9 meters per second. Although the VF, we are not sure of what will be the VF. Ask for ball number. Let's start from there. Ask your question.
let's say ball A was thrown to a maximum height of that 30 meters from the ground.
Mm.
And then it returns. Then it's supposed to return back to the ground. Do we say let's say we're taking upwards as positive, right? Is the displacement going to be negative or positive?
If ball A was thrown what?
Upwards.
So you want to know whether the displacement is a positive.
Negative.
The displacement is positive. It's in the positive direction. Because
when I say upwards is positive.
Yes, it's above the point of release. It's not below. The reason why we put that negative is because the point of projectile or the point at which the ball was projected, if it was at a certain height above the ground, that's when you put it as negative, the displacement, because the ball is going to go to move a displacement below the ground until it hit the ground. But in this one, the displacement will come to 0. The displacement, it will still come to 0 with the reference from where you have projected with the reference from where you have projected the ball. Remember that change in y it's relative to the position of reference. To the position of reference. Yes, if your reference, like the one which worked yesterday, it was somewhere there, and the reference point you project comes down to the ground. So with the reference to where you have projected, what is this change in y? With the reference to where you have projected the ball. Do you understand? With the reference to this one. So change in y will be what? It will be a negative, isn't it?
Yes.
Because this will be your 0 point, your reference point, your 0 point. And this ball is coming below. That's why it's a negative change in y. But if you are projecting it from the ground, goes up, coming back to the ground. So what is the reference point? Depending with the change in y, the reference point was 0, and they are coming back to 0. So change in y becomes also what? What is
0.
The change? 0, relative to the reference point. That's what we are talking about.
Okay.
Then there's a situation where you throw a ball upwards, like this, from the ground. It goes up, it reaches a certain point, but it does not come down, it reaches there. With the relative to the reference point, what is change on y? Change in y is this one. Is it a negative or positive? A positive change in y. Because your reference point was here. You throw the ball, reaches the terminal velocity, it came down, it reached a certain height above ground, but it did not come to the ground. So the change in y is going to be what? A positive.
Positive.
Yeah, so you must master those things. Reference to where you have started. Okay.
Yes.
So in our case, for ball number B, let's go to the reference point. For ball number B, we are saying the final velocity minus the initial velocity, which means the final height minus the initial height. That was what we are calculating there. So what is the initial height?
The initial height is 30 meters above the ground.
Yes, so which means here, this is ball B. You are taking upwards as positive. And then this is the ground. This is the ground. We are here. This is the ground. And we know there is 30 meters. This distance is 30 meters. And your VI, we said it's 9 meters per second. So which means the V initial, we know it's 9 meters. But in this situation, we are taking upwards as positive. Up is positive in this scenario. So if up is positive and this ball is being thrown downwards with a velocity of 9 meters per second. So let's look at the setup, how the equation was set up there. So you come, we check. We are saying change in y while we are taking up as positive. So y minus 30, which means yb minus 30. Why are we referring to yb as the final? And why are we referring to this as the initial change in y? So this is the final y minus the initial y. Do you agree?
Yes.
Yes. Why? Because the initial distance where I'm throwing, it's not at the ground. It's not 0. Do you understand? It's not 0. I'm starting upwards at a height of 30. That is why we have subtracted that. But as I'm going down, any point where the ball is going to be along this line, anywhere along, as I'm going down, that value, we call it YB. Anywhere where after this point of release, anywhere downwards, that value, I call it YB, as I will be going down. And as I will be going up, we indicated any value that as you be going up there, we call it YA, any value. From the point, initial point was 0. And then with this one, the initial point was at 30, at a height of 30. Why is it at a height of 30? Because we said the 30 is upwards from the point of release. So it can't be negative 30, because we said upwards is what? Is 30. So where the ball is starting,
It's
this is,
positive.
yes, this is 0. And we said upwards is starting at positive what? Positive 30. That is where,
Positive 30.
yes. So I'm starting at positive 30, going to YB, and YB is going downwards. Anywhere a height of YB going down. But we know if downwards is positive, so which means my final Y, F will be YB. My initial Y, it's a positive 30. But from the rule of change in Y, it says Y final minus the Y initial. So which means my Y final, it's YB, as I'll be moving downwards, minus that positive 30. That is where we are getting that equation from. Then we start now. Since we are saying downwards is positive, now we are substituting our values. We said here in this situation, up is positive. Up is positive. So if you are having a velocity which is coming downwards, it's represented by what?
-9.
-9. That's where this 9 is coming from. The first 9. So before we talk about these values of the negative, let's start by that 9. -9 meters per second is downwards. Then the acceleration as you are going down, downward, the acceleration, as you are going upwards, we said the acceleration is what?
-9.8.
Yes, as we are going, whenever you take upwards as positive, the acceleration that corresponds with upwards is positive. The upward motion is positive. It's negative because we are calculating all these calculations which we are calculating. We are taking up as what? As positive. Up is, yes, upwards is positive. Upwards is positive. So which means the acceleration, if up is positive, which means the acceleration, here it was also 9,8. Also here, it will be also 9,8. Because we are not taking it down as positive. If down was positive, VI will be +9. And also acceleration will be +9. But since we are taking up as positive, that -9, the V initial, it will be -9. And and the acceleration here, it will be also a negative because we are taking up as positive. Is there a question in terms of acceleration? Then in terms of time, remember this is a quadratic equation. If B it was a second after. So a second after, which means the T was shifted to the right, isn't it?
Yes.
The time was shifted to the right, 1 minute. So shifting to the right in terms of the quadratic formula, a shift to the right, what do you write here? If the T was shifted to the right in terms of quadratic, we say a shift to the right. Do you indicate with a +1 or a -1?
It's a +1. A
No,
shift to the right to the +1.
No. In terms of mathematics, quadratic equation, a shift to the right, it's not a -1. If I have a parabola here, which I'm having, this is a normal parabola. Then I say, now give me the equation. This one, it will be y. Suppose this is t. So y is equals to t squared. That is the parabola. Then I shift this t to the right. 1 unit, which is 1 second to the right. So which means the graph like to be cutting here at this point, which is a 1. How do you write this parabola in terms of the quadratic equation? That shift, is it +1 or y is equals to t? It will be t minus 1 squared, which means the shift was shifted to the right. So this value is now a +1. Instead, for this x-intercept in terms of t to be sitting at 0, now it's sitting at 1. So you don't say for quadratic, it's always the opposite. If it's -1, I know my graph has been shifted to the right by 1 unit. But if it's +1, I know the graph has been shifted to the left by 1 unit. Do we agree on that point?
Yes.
Yes, because this is a quadratic equation. So if my graph was shifted to the left, which means it's cutting at -1, then the equation of this graph, if the y-intercept is representing t, the x-intercept is representing t, and the y is representing y, which means y will be equals to t plus 1 squared. But in our case, the time increased, which means it's a shift to the right. And the equation which we are dealing with, the quadratic, so a shift to the right, which is -1. So do you agree to why they put a -1 there?
Yes.
Because the time increased. For ball Y, they had to delay and wait after 1 second. Then they projected that ball. So the time it took for ball A, for ball B, it took 1 second more. Is that correct? 1 second
Yes.
more in terms of quadratic, it's a shift to the right with 1 unit, which means you represent with a negative. So wherever there is t, now you replace t. Any t on that formula, you replace it with a t minus 1. Where there is change in t, is with t minus 1. Now, because of the 30 came to the right, so this 30, it will be, we are making the 30 coming to the right, which means we are making y subject of the formula.
Yes.
All right, so we are here now. So yb minus 30 is equals to that. So which means when it comes to the right, what does it become? If it comes to the right, it will be 30.
80 plus.
All right, so let's check here the setup which we're talking about. So while we are there, which means everything is sorted there, -9. All right, so the 30 comes to the right, becomes 30. Okay. All right, so which means this one, t minus 1, which means it was completion of square. And then, all right, let's simplify it nicely so that we don't confuse each other. All right, so we are saying y b minus 30 is equals to, so we had our values for b, which is vi negative 9 t minus 1. So let's start from there. Negative 9 delta t minus 1. Negative 9 delta t minus 1. And then from there, we also have plus half at squared plus half at squared. So you indicate the positive plus half multiplied by the acceleration, negative 9,8. Half at squared. And then the t squared, which was t minus 1. Then you square it. So this is our equation that we want to solve. All right, before we go any further, yb minus 30 is equals to, let's expand here. Or before we expand, which means the negative is going to be like this. So it will be negative 9 multiplied negative 9t. Then the negative and the negative, which means we are expanding now. Negative and negative, it gives you what? Positive.
Positive.
Positive 9.
Yes.
That, and then
yes.
Because of the signs there, we have a half times a negative. So which means lastly we get a what? A negative what?
Negative 4.9 delta t squared.
Negative 4.9. But it's not delta t squared. It's negative 9 bracket t minus 1 squared. Can you see it? It's negative 9 t minus 1 squared. Because that t, it's inside the bracket, t minus 1. This one is just t. Delta t, that one is delta t minus 1. So which means it's one bracket. We have not expanded that t square. So which means yb minus that is equals to negative 9t plus 9 minus 4,9. Then we expand that bracket of t. How do we expand that bracket of t? It to be 4,9 multiplied by what? T squared minus 2t, isn't it?
Yes.
Minus 2t plus 1.
Plus 1.
Plus 1. Then you close your bracket. Okay. Then now we expand further, which means you mean yb minus 30 is equals to, we still have our 90 plus 9. Then now we are expanding using that negative. Minus 4,9.
9. 9.
Plus 9,8. 8t. Can you see?
Yes.
Then minus 4, 1.
9.
4,9. All right. Then you group the like terms together. Now you come and say YB is equals to, and remember, this is a T minus 9T plus. So let me not confuse this one. Minus 9T, this is a T. And then we put a proper plus so that our numbers are clear there. It's a plus there. It's a T plus 9. So it's my YB is now going to be positive 30 minus 9. Then we check another number. Which
minus
one?
4.9.
Minus 4.9. And then the T's. But remember here, we said this one is a plus 9. This one.
Plus 9.
Yes, it's a plus 9. So it's a plus 9. Like that. So it's a plus 9 minus 4,9. Then now we are going to the T's. So which means minus 90, which is this one. Minus 90, which is that one. So minus 90. And then we are having another T, which is this one. Minus 90 plus positive T. So which means minus 90. Let's put those T's in a different color. Minus 90. Then plus positive T. Positive 9,8. Then we put a T there, the different color, to avoid confusion. T. Now we are left with the T squared. So the T squared, how many are we having? We are only having one, isn't it?
1. Yes.
We are only having one, which is only minus 4,9 T squared. So which means we just add plus minus 4,9 T squared, which give you minus 4,9 T squared. So this is our quadratic equation, which we are having for YB. And then in the end, what are we having as our YB? We group like terms together. So let's group this. What do you get?
34.1.
So which means we are saying our YB will be equals to 34.1.
1.
Then the T's, what do they give you?
0.8 T.
It's a positive 0.8. Then T. And then minus, isn't it?
Mm.
So it will be minus 4,9 T squared. And what do you get when you solve this quadratic equation? So which means these are the two equations that we are having. And here, what did they get? So did we arrive at the same answer?
Yes, but since they
what?
did get the same answer, but since they said 30 minus into negative, that's where I was confused.
Oh, okay. So you are saying, which means they, instead of 30 minus, it was supposed to be 30 what?
30 plus.
Oh, okay, okay. Which means here, instead of this minus, they are supposed to say 30 what? Plus. Is that what you're saying?
Plus.
Yes, yes.
Yes.
You know what they did? What they did was that,
You know,
yeah.
I didn't understand it when I was looking at it because I had got it wrong. When
Mm,
I was looking at it, the thing that confused me now
mm.
was that um the thing delta y I didn't know whether if my delta y was positive or negative.
Oh, but we have explained better that delta y, it's as we are looking downwards, it's YB minus 30.
Yeah.
30 was a positive, yes, because it's upwards.
Yes.
Yes. So this one, yes, you are right. Yeah, then you are saying 30 plus, isn't it? Plus what is on the right, isn't it? That is the only way you can get out this answer to be the same with this one, what you are having. So those two can only be the same if you have treated them like this. So which means by putting 30, we are adding what is on the right, isn't it? We are not subtracting, but we are arriving at the
Yes.
same solution, at the same solution. So which means you solve these equations simultaneously, which means you have YA. What was our YA for the first part? The YA which we got, which we were working here, which we said the YA was correct.
16 delta t
So YA
um
16 t minus 4,9 t squared. Yes, which is that delta t. So here you'll be equating. So 16 t minus 4,9 t squared. So what does that mean if you interpret those two minus 4,9 t squared? So what it simply means is that you want the position when these two balls, so which means you are measuring YA as A is going upwards. So somewhere there, YA above the ground. And then YB, you are measuring it starting from somewhere there, coming downwards. So it reaches this point, which means this is your YB, somewhere there. So this point where they meet here, this ball is at YB, and that ball is at YA. Can you see what is happening? After we've
yes.
considered the delay. So this is how we are, this is your ground, your reference point. And this is the top of the building. So this is the motion, what is happening. So the question now is asking the height. The question itself was asking, they are saying calculate the what? How high above ground will ball A, or above ground ball A will be at instant the two balls pass each other. So which means here, when you are solving, you are now solving those two equations simultaneously. Is that not so? Why are we saying
Yes.
simultaneous? Oh, we are simply equating that those heights, they should be the same. Those heights, they should be the same. While B is moving from the top.
Yes.
So which means this is the one that we got for B, which is on the right. And this is the one that we got for what? For A. Then now we are equating, we are saying,
Okay.
since these heights, they should be the same. So this height which I'm having here, when these two balls they meet, this one will be H. And this one would also would have traveled the same distance at that point when they are going to meet. But the height which they just want above the ground, which means this, when they meet these two balls, they meet at that Y, when this YA and YB are equal. That's when those two balls they meet. So this one would have covered a certain distance. That one would have covered a certain distance going down. So that's why we came to a conclusion that YA should be equals to YB. Then you equate the equation. So what you were not getting, now I get it. That was the issue of the sign. That everything was
Yes.
fine. Everything was fine. So take into account that positive, if you take positive S, if you take positive S, Y as positive, upwards as positive, acceleration is always negative. It does not matter now whether you are taking down now. So the trick here was where you were going to be tempted to put a positive was here at this point. Can you see this acceleration?
Yes.
For B, especially for B. For A, it's fine. But where you'll be tempted to put a negative, what was here, this one, if you fail to interpret it. Because you might think that since now I'm going down, since now I'm going what? Downwards.
Positive.
I have to
It
pick
should
this
be
one
positive.
as a positive. Yet you said that down is negative. So if you want the 9, negative 9, 8 to be positive, also the negative 9 should have been a positive. You get it?
Yes.
That is the idea. Supposed to be a negative. Okay. So that was the tricky part which you needed to master there. That was the trick part which you needed to master. All right. So let's continue. We just have one other question for projectile. But at least now with this one, I know you would have mastered most of the questions. Okay, vertical projectile. We just pick one of the questions here. So these are the definitions that you should just know. Free fall. What do we mean by distance, displacement, speed, velocity, rate of change of position, acceleration, rate of change of velocity, position, which means the position is measured relative to the reference points, which is a key thing when you're dealing with projectile. This reference point, it's very important.
Yes, sir.
Otherwise, it will take you out. That change in Y, reference with the reference point. That's how we are determining the change in Y. So free fall is just having, it's an object which is just experiencing one force, which is the gravitational force. That is the gravitational force. Let's have one problem to solve. All right, let's just work on this one. Let's just work on this one.
Okay.
Just work on this one. That we just want. So they are saying a child throws a coin vertically upwards from a window of a high building with the initial velocity of 15 meters per second. It strikes the ground traveling at 35 meters per second. Ignore the effects of air resistance. So initial velocity 15 meters per second upwards. Then you are given VF. Can you see the VF? And do you know the height of the building? Do you know
No.
this? It given this height of the building?
No, it wasn't given.
So which is a different case today. Yesterday it was given. So let's see. Describe the motion of the coin. How do you describe the motion of the coin? As the coin is going upwards and downwards, how do you describe the motion of the coin?
I can say it was projected.
The motion of the coin. We are describing from the way it was projected until it reaches the terminal velocity, then it comes downward. So you need to describe that motion of the coin. So
You say that the ball was projected vertically upwards at 15 meters per second and reached a maximum height above the building. And then it underwent a free fall from the maximum height to the ground, and it struck the ground at a velocity of 35 meters per second.
At least, yeah, try. Let's try it. Then for the second one, what do you do? For number 2, calculate the time.
We say VF is equals to VI plus acceleration delta T. Our final velocity is 0 and our initial velocity is 15 meters per second. And our acceleration, if we take upwards as positive, is going to be negative 9.8.
Yes, calculate it and you tell me what is delta T. Calculate it.
And then delta T is
Calculate it. Tell me. That's punching
1.53
seconds. Yes, which is correct. That's correct. So delta T, you're saying it's 1.53 seconds. And the motion of the coin. In other words, when they say describe this motion, you just say, what is the gravity of this coin throughout the motion? But if you take upwards as positive, what will be the gravity? Negative
9.8 meters per second downwards.
Meters per second squared. Not meters per second only, but meters per second squared. All right, downwards. So the motion of the coin, it will be just to indicate that this is just a constant uniform acceleration. But this acceleration is downwards. So that is we are describing it as it's just, this coin is under constant uniform acceleration, which is downwards. So it's a constant uniform acceleration. By uniform, it means it's constant as well. So uniform acceleration, which is downwards. Which is downwards. So that is the motion. You can describe it like that. It is simple. Which means we have mentioned or we have stated that the coin is going downwards. So the coin is going downwards. And the acceleration throughout the motion is still negative. Because you have taken up as what? It's positive.
Positive.
You've taken up as well. So calculate the time taken for the coin to reach the ground. Calculate it for me. Which formula are you going to use? Let's start with the formula so we can assist each other. So the final we are given VF is equals to?
VF is equals to VI plus A delta T.
As A delta T. So which means, what is your VF?
Negative 35.
Excellent. So your V, that's where most people they lose the marks. It's negative 35. It's downwards. Then what is your VI?
15.
Positive. Plus the acceleration as we are going up.
Negative 9.8.
Then so for T. Negative 9.8 T. So what is T? Change. Look, solve for T.
5.1. 5.1.
5.10 seconds.
Yes.
Okay. And then the distance that the coin traveled when it hits the ground. So we are looking for the distance, the coin that it traveled when it hits the ground. So you have distance and you have position. So the distance that it traveled.
We're gonna say Vf squared is equals to Vf squared is equals to Vi squared plus 2 times the acceleration delta y.
Yes. So calculate the distance the coin traveled when it hits the ground. Yes. What are you getting as your distance? What are you getting as your distance? What was the distance?
51.02 meters.
But when you're calculating, did you get a negative?
Yes, negative 51.02.
So what does a negative tell you?
That the ball is thrown down, is going downwards.
The negative tell you that reference point where is indeed this is your reference point, which is 0.
Yes.
So if you get a negative, which means that distance which they are talking about, it's below the reference what?
Point.
Below the reference point. So the 51 that you are calculating is this one, which is the height of the what? The one which they are saying negative 51 meters. It's not the maximum height above ground which was reached by the coin. No. The distance which the coin traveled, which means below the reference point. So do you understand it now?
Yes.
Yes. So whenever you calculate that change in y, you see it as negative, then you know it's below. That's why when you're asking me, say when the coin is thrown and comes back, what is my change in y? The reference point is here, and when I are here after. So which means the change in y is what?
0.
0, like what I indicated. Reference point is here. After some time, you're upwards somewhere there. So the change in y to be positive because it's above the point of release, the reference point. Once you master those tricks, we are done. All right, let's go to the last one. Calculate the position of the coin relative to the top of the building. Relative to the top of the what? Of the building at 4 seconds. So where is the coin at 4 seconds? That's what they're asking. The position of that coin at 4 seconds. Where is that coin? Calculate the position of the coin relative to the building at what time? At 4 seconds.
It's negative 18.4 meters. At 4 seconds.
Number 2.4. Number 2.4 was the height of the building, isn't it?
Yes.
Which we calculated as 51. Isn't
Yes.
it? Yes.
Yes.
And the total distance that the coin traveled, the total distance that the coin traveled, which means you are not only adding a 51, which means the total distance, it will be for the whole parabole, this one. That one is only for the height of the building that we calculated. For 2.4, it's 51, negative 51, which means below. But if they want the total distance the coin traveled, which means the building is here, reference point, then the building, what is the height? For it to reach maximum height, you calculate. And for it to go back again, you calculate. Then you add the height of the what? Of the building, which is 51. Now the coin is down there. So this 51 plus twice the height of going up is the same with the height of going what? Down. So this distance it will be twice. Then you add. So what is the height? The maximum height reached above the initial point. So that you can calculate the total distance which the coin traveled. So the total distance which the coin traveled, total distance. Now we are starting from that point, top of the building, reaching the maximum height. What was the change in Y? This one. What is this change in Y? That one. So it will be times 2 plus 51 meters. So what will be that answer? For number 2.5. For 2.4, yes, you are correct with that one. Then you calculate your...
If I multiply it by 2, it's 22.96 meters above the ground.
Then when you add it to 51, then add it to 51, you get what?
I get 73.98.
Yes. So which means that's what you do. When they say the total distance which it traveled, the coin. So from the start, the distance it traveled to the maximum height, coming back from maximum height to the initial reference point here. Then with the distance of the building, then you add it. So it's 3 figures that you are going to add. Going up, going down, plus the one which is below. So we are correct. Then the last point is we want to find the position after 4 seconds. Which formula do you use then?
Delta x is equals to VI delta t plus 1 over 2 acceleration delta t squared.
Correct. So let's calculate. Let's calculate. So at what position relative to the top? Relative to the top.
It's negative 18.4.
So how do you interpret that change in Y of negative 18.4? What do you say?
18.4 meters
Below
the building.
Top of the building. So it's 18.4 meters. Somewhere here. This is the top of the building. So the ball will be somewhere there. Below. It's going down. Not above the ground, but below. Then they'll ask you how many meters is the ball above the ground after 4 seconds. So you see that question, it's very tricky because they don't want the one which is below. So which means the one which you are going to calculate, the question it will be like this, which means yourself, you are able to calculate this distance. This is the top of the building going downwards. Then they will ask this one. They know that they want this distance, which is above the ground, which means now they want this one. So first you must calculate the one which is below by using that formula. So the formula will only give you this one, the negative 18,4, which means it's for 18,4 meters below there. So if they say what is the distance of the coin above the ground after what? 4 seconds. So which means you have to subtract the height of the building. We said it's what? 51.
51.02 meters above the ground.
Then you subtract 51 minus 18.4, what do you get? So that you know the height above ground, if they asked that one. It will be how many?
32.6.
So that's the method that you are going to use. 32.6. So that is the method which you are going to use if they ask you above the ground. Because your method of calculating from the formula, it only gives you the one below the building after 4 seconds. It does not give you the one above, no. For the above the ground, you know that you have to subtract. If once they say they're above the ground, now you have to subtract. You get the trick?
Yes.
So all the answers were correct. What you got, 1,53, 5,10, and then negative 51, which was 51 meters below or the top of the building. It's the same height of the building. And then the one for calculating the total distance traveled, which I said you add, it's twice, going up and coming back plus 51. Then lastly, this one, where is the position after 4 seconds?
Negative 8.
It is negative 8. So what does that mean? It's below the top of the building. 18,4 meters below the top of the building. All right, so I think you have mastered projectile. It's only about sketching the graphs, etc., which might be left. You might touch up on some questions of graphs. But calculations, I think you're fine. Okay. So let's stop here for now. We'll continue tomorrow, isn't it?
Yes.
Okay. We'll try to touch up on the graphs. Try the graphs. If you are studying, work on the graphs now.
Okay.